going to be chapter 1, chapter 21, and I will use the PowerPoints together with embedded material and also with actually I'm gonna use some of the problems from your textbook for solutions. um, I might also refer some of the examples, but I will leave the examples for you. You're gonna work on them and read them, and then if you have questions, let me know, and I'm gonna add here more problems. Okay, chapter 21, we are going to talk about electric charge and electric field. And we will learn today how to calculate a force between two charges, how to calculate the electric field that is resulting from a charge. Either this is going to be a point charge or is going to be a distribution of charges. You will see that chapter 21 is going to come, and all the chapters, they are going to come in, let's say, short lectures, because it's easier for me to upload. We will study how objects become electrically charged. What is the origin of having these charges, and how we know that electric charge is conserved. We will use Coulomb's law to calculate the electric force between 2-point charges. And later, we will actually use again an equation derived from Coulomb's law to calculate the electric field. And of course, we need to be able to distinguish between what is the meaning of an electric force and what is the meaning of an electric field. We're going to also find how to, draw electric field lines and how they are going to reflect the magnitude, something about the magnitude and direction of electric fields. Also, we will be able to calculate the properties of electric charge distributions, including dipoles. And what does that mean? These are the sections in your textbook, and maybe I'm highlighting the most important, like the electric charge, the conservation of electric charge. We classify materials into conductors, insulators, induced charges, Coulomb's law, and we are going to go back to superposition of forces. Then here, what you are going to do is you should review how to add forces, or I will say in other words, vectors. We will also learn something about electric field and electric forces and how they are really related. We will also calculate the electric field of a point charge and how an electron is going to behave in a uniform field. Also, we will do some electric field calculations for a distribution of charge, and then we will learn about electric field lines and electric dipoles. Now, something that may be very interesting is we know that water means life, and water is the one that is making our life possible. And I will say our cells, they need water in consumption, and everybody is telling you that you need always to have water intaken so that you will be okay. Now, something that is really very important, that water is a very essential I would say factor that is responsible for dissolving most of the biological molecules. And in this chapter, we are going to understand what electrical properties of the water that is making it a good solvent. Now, of course, we will, like mostly this course is about electromagnetism, and the first field that we are going to start talking about, it is electrostatic in this chapter. And we need to know that the electrostatic force, it is one of the four fundamental forces in nature, which are the strong nuclear force, and the second one in strength is the electrostatic force, and the third one is the weak nuclear force, and the weakest one is the gravitational force. We will start here with the electric charge. We are going to look how we can charge objects, and some ideas about how to charge objects, and also how to calculate forces between charged objects, and how to calculate the electric fields. Now, if we look at this picture here in front of us, we have two plastic rods, and we have a fir. And I will say the electrostatics, it is when we have electric charges that they are not in motion, okay? And I will say I can rub the plastic with fur, and then I will cause that, these plastic rods, both of them, if I will rub them, they are going to have negative charge. And of course, if I have two of them, and then we will see that they are going to repel each other. Now, also, if we have glass and silk, and when we rub glass rods with silk, the glass rod will be charged, but it will be charged positive. And if I have two of them, of course, they're gonna repel each other. But if we will have the plastic, I will say the charged one with the glass one, which is also, charged, we are going to find that they're gonna attract each other. Now, we have here this kind of experiments that they're gonna show that we have two types of charges, positive and negative, and when we have like charges, they're gonna repel each other. When we have unlike charges, they're gonna attract each other. Now, why that, let's say, plastic rod did gain that negative charge when it was wrapped with fur, why the glass rod was actually gaining a negative charge when it was wrapped with silk. This is really the basic idea. It is hidden in what is called the electric charge and the structure of the matter. Now, we know, of course, most of you are familiar with the structure of the atom, where we have the nucleus, and inside the nucleus we have what is really called the nucleons, and the nucleons, they are protons and neutrons. These are the heavier parts of the atom. I would say the nucleus, it is a very concentrated object inside the atom, which has only protons, which carry positive charge, which they have the color red here, and neutrons, which are the gray. They don't have any charge. And also we have electrons, and these electrons are actually, they are going in orbits around the nucleus, and they have negative charge. When I have a neutral atom, I have the same number of protons and electrons. And therefore, if I will say, let's say Na, which is sodium, is going to have 11 protons is going to have 11 electrons revolving the nucleus, and then I will say plus 11 minus 11 is going to be 0. Then the charge that is going to appear on Na atom is going to be 0. But okay, what if I will have kind of a process that is going to be removing one of the electrons? Then instead I'm going to have, let's say, 11 electrons, and um, uh, um, I will have 11 protons and 10 electrons, and therefore is going to have a charge which is a plus 1. All right, and then here a positive ion, it is an atom that which one of or more electrons are really removed, and I can say that mostly I will have the positive ions forming um, from the first, let's say, three um, groups of the periodic table. On the other hand, the negative ion, it is an atom with an excess of electrons, then it did gain one electron or more. Now we know that the electron and the proton, they have the same electric charge, and the magnitude of charge of the electron or proton is a natural unit of charge. That means any charge in the universe, let's say Q, is going to have n times I will say Q electron. It's a multiple of what electronic charge. Then and the smallest charge that exists in nature, it is the electronic charge. And we can say, based on this formula, that all observable charges are really quantized in this unit, which means they are multiples of the electronic charge, which means just whole numbers. You don't have any fraction. Also, we know that charge is conserved. Then in the first example, when I was rubbing the fur with the plastic rod, I mean with the fur, the same amount of electrons that were lost from the fur, they will be the same electrons, the same number that was gained by the plastic rod are really the same ones that they were lost or donated by fur. Also, we need to know that some of the materials, we call them conductors, they have a plenty or so many electrons that they are really free to move. And I will say here, the metals, usually we approximate their structure to be having heavy ions, positive ions, and they as if they are swimming in a sea of electrons, because the electrons are really very far from the from the nucleus, and they are mostly as if they are really shared by the whole metal, not by each atom. And of course, they are really charge carriers, that they are really good. Although also some of the materials, we call them insulators, because they don't have these free electrons. In the figure here, I have a metal ball here, and I have a charged plastic rod. And if I have a copper wire, which is also a very good conducting material, then I can charge the metal ball with negative, and then I will say now I will have repulsion between the plastic rod, and the negatively charged ball. But if I would bring a charged glass rod, this is gonna cause I will say, attraction. Now, some of the times we can charge by induction. Induction means you know that this is a charge that is not a transfer of an actual transfer of electrons. Okay, and this is how we charge by induction. We start with an uncharged metal ball, and it has a support and insulating stand so that we will not have these charges going through the ground. And then if I will bring a negatively charged rod near that ball, I will not touch, I will just bring it closer, and then I will say the end that is closer to the rod is gonna accumulate positive charge, and the other side is gonna have the negative. This is kind of splitting of charges, and actually I can connect a wire between the sphere and the ground while the rod is still there, and then I can make that negative charge go to the ground, and then I will have my sphere here is gonna be having positive charges. Now, also, I will say, you might find that your comb is attracting your hair, or you might find that a charged balloon is gonna stick to the wall, and this is really because we have something called polarization. Then I will say here, the comb here, if it is negative charge, you will find there is a slight shifting or splitting of the charges, and that is meaning the positives they're gonna face the comb, and the negatives they're gonna be on the other way round, and therefore we are going to have what is really called polarization. And this is the idea that we have in electrostatic painting, where we are going to, have, let's say, the surface that I wanna, let's say, paint. I'm gonna have it positive charge and the paint negative charge, and then I will say they're gonna be attraction, and therefore I will have that painting. Okay. I'm gonna stop here, and then I'm gonna see you in a little bit with another video.